Well, hello again. Let's now look at voltage dividers. All right. So I'm going to take a circuit here. I'll sort of make this generic. So we're going to call that, once again, E. And I'm going to deal with 3 resistors. So here we go. All right. We'll call these R1, R2, R3, and we're going to talk about a current I, which defines the voltage across these guys, plus minus, plus minus, plus minus, okay? And I'm going to be looking at this voltage plus minus V3, okay? So look, let's go ahead and take a loop and sum the voltages, okay? So if we do that, according to a convention of if I'm going from a low to a high, I'm going to call it positive. What do I get? I get E, and then a drop. That's a minus I, R1, dropping, minus I, R2, and of course a minus I, R3, and all of that is equal to 0. Okay? So I'm going to solve for basically I. So taking these terms to the other side, what do I have? I have E is equal to, factor out the I, I've got R1 plus R2 plus R3, closing the bracket. And so therefore I could say that the current I is really equal to what? E, and it's divided by the R1 plus R2 plus R3, okay? Now, just as a little recap again, the alternative approach to summing voltages, all right? So I'll just call this the alternative approach, right? So with my alternative approach, what am I doing? Well, as I go around the loop, if I hit the minus, okay, first I call it minus, and come around, if I hit the plus, I call it plus, and so on. So looking at this, starting here, I hit the minus, so I call that what? A minus E. Come here, I hit the plus, I call that an I times R1, hit a plus, that's a plus I times R2, plus I times R3, and all of that is equal to 0, okay? So once again, I can take the E to the other side, and I have what? I, open up a bracket, R1 plus R2 plus R3 is equal to E. And of course, really, this is the same as what we had above over here. And so again, I can be saying that I is simply equal to E divided by the R1 plus the R2 plus R3. So we wanted to find the V3 here. And so V3 is going to be what? The current I times that R3. Okay, so let's just do that. So we can say V3 is equal to the current I, which is what? E divided by R1 plus R2 plus R3. And that's going to be multiplied by what? The R3 resistor. So we can really say that this is equal to, I'm just reordering this, it's really equal to what? R3 over the sum of the resistors in this circuit, which is R1 plus R2 plus R3 multiplied by our source voltage over here, which is E. And this is our voltage divider expression, okay? This is an important relationship. I think it's useful to remember this. So, for example, if I wanted to find the voltage, let's say V1 that's sitting here, V1 would be equal to what? Well, it's just basically the R1, isn't it? So we write down R1 divided by the sum of the resistors in the circuit, which is R1 plus R2 plus R3 times what? E. If I wanted to find the voltage, let's say here, plus minus, and we call that V2. Well, then V2 would be what? It would simply be the R2 resistor divided by the sum of the resistors in the circuit, which is R1 plus R2 plus R3 multiplied by our source voltage over here, which is E. And so, as I say, this is a voltage divider relationship, which is very important, and it's certainly worth you kind of committing that to memory. Okay, let's take a little example here. We want to find that voltage V2, and I really would like to use a voltage divider relationship in order to do that. Well, in order to use a voltage divider relationship, it really has to be a series circuit. So what we need to do first then is really combine these two resistors together, right? So what we've got is a 7K and it's in parallel with a 3K. And that is equal to the 7K multiplied by the 3K over the sum of the two. So that's a 7K plus a 3K. That's the parallel equivalent resistance. And if you work that out, that comes out to be about 2.1K. All right. So we can replace these two with like a single resistor now of a value of 2.1K. So now we've effectively got a series circuit, have we not? And so we can say that voltage V2 is really equal to this 2.1K resistor divided by the sum of the resistance in the series circuit, which would be what? The 4K plus the 2.1K, and that's multiplied by the source voltage over here, which is 20. And if you care to work that out, V2 is going to be equal to 6.88 volts, okay? All right, have a think about that. Maybe you could work out the voltage, let's say, across the 4K resistor plus minus. We could call that V1. All right, I'll see you next time.